Hey everyone, back home. I'm here at the Subaru Telescope Observatory base station. We're about to head inside and talk to some real scientists to do some real observation of things like black holes and planets. So let's go.
My name is Michael Latowski.
How did you get here? It seems kind of odd that an Alberta boy would end up in Hawaii running telescopes.
Yeah, it's kind of an odd story, but yeah, I grew up in an area northeast of Edmonton, in a rural area, so the nights were dark and long during the winter, so I was always fascinated by the night sky. But so I was always been interested in astronomy, and when I graduated from high school, I was trying to figure out what I wanted to do, and astronomy just didn't seem like a practical thing. I mean, how am I going to get a job in astronomy? I want to have a job, make some money. So I did a practical thing. I went to NAOJ and took electronics engineering technology and worked in the computer field for a while, repairing computers, installing computer networks and software. And then decided that that wasn't going to be enough, so I decided to go back to university. So I decided to follow my heart this time and go take physics and astronomy and chose the University of Victoria for a few reasons. One is it had a very good astronomy program. Two, the largest telescope in Canada was right nearby there. And three, they had a co-op program in astronomy. So I followed that path, and during the co-op program, I did a number of work terms, and a couple of them were over here at the Joint Astronomy Center in Hilo, specifically for the United Kingdom Infrared Telescope. And so I got a lot of experience there and made some contacts. And then when I was on my final work term at that observatory in Victoria, I saw a posting for a job at this facility, and I was going to be graduating in a few months, so applied and been here ever since and enjoying it.
Wow, very nice. That's an impressive route to get there.
Yeah, it was. I didn't know, where it would lead me, but I took a chance, and it worked out.
What do you think is the coolest thing about your work?
The coolest thing is I get to operate one of the largest, most advanced telescopes on the planet, so that's pretty cool.
So Jake was wondering how long it takes to pan 360 degrees. So how long does it take you to move that telescope?
Okay, Jake, we slew the telescope at a speed of 0.55 degrees per second. So if you want to go 360 degrees, that's roughly 720 seconds, which is about 12 minutes. But one interesting thing is we can't keep rotating the telescope forever. All the cables that supply coolant and power and networking comes up through the center of the telescope. And so those cables can only rotate so much in one direction, and then you have to rotate the other way. You can't keep rotating.
We already mentioned that this might be kind of hard to answer, but Jake was wondering, what's the farthest object that you can see with it, before things start to blur out?
I believe the farthest object we've seen is about a redshift of 7. So that's how we determine how far objects are, is by how far their wavelengths have shifted. So the universe is expanding, and as things expand away from you, the wavelengths of the light get shifted to the red. So we can measure where something is right now and where it should be, and compare the two wavelengths, and that gives you a redshift. So a redshift of 7 is about 13 billion light years away. So that's about 750 million years after the Big Bang. So it's pretty far.
Ben was wondering, how do you maintain it all? Like, how do you keep that telescope up and operating?
Well, we have day crew that does go up every day during the week to maintain the telescope. So there's a huge day crew staff. We do an annual maintenance. The telescope was built by Mitsubishi from Japan. So they come every year and they do annual maintenance. And then every 3 years we recoat the mirror. So actually this summer we're going to be doing another recoating. We actually remove the mirror from the telescope and apply a new coating of on it.
So do you have to move it from its housing to do that, and then with the big crane and such?
Yeah. There's all kinds of equipment. You have to lower the mirror onto this trolley, and then you pick it up off the trolley and lower it down to the ground floor in our building. And from there, it goes onto another trolley and then get moved to different positions. So first we'll have to wash off the old coating using hydrochloric acid mixture and make sure it's all sparkling clean, and then do an inspection of it, see if there's been any damage over the past 3 years and fix something. And then there's a vacuum chamber down there that's big enough to put the mirror in, and we zap the metal on electrodes, and we charge up these electrodes, and the metal gets vaporized and lands on the mirror.
I have one more question, which was if you could add or change anything to your telescope, what would you like to add to it?
Our telescope is pretty advanced and pretty versatile. So of all the really large 8 to 10 meter telescopes up on Mauna Kea, it's the only one with a prime focus camera. It's very versatile. So we've got a slew of instruments that are specialized to look at certain things. They've really thought of most things that astronomers want to use. So from an operations point, the only thing that would make it better is if you could operate the telescope from sea level, because being up in high altitude is not the most pleasant place to work. So there are telescopes that have been changed to do that, but right now we don't have plans to.
Right.